Good afternoon to one and all. I am R.V. Kiran, Assistant Professor, Department of Mechanical Engineering. Today in this class, I am going to explain you about the classification of cams. So today our topic is based on the what are the different types of classification we needed to do in the cams and what are the types of cams. So generally depends upon the shape and surface contact. And this is my 36th lecture regarding to the subject kinematics of machinery. So in the yesterday's class, we have discussed about the what is a cam and what is the function of the cam and what are its pair, that is the follower, and we have discussed the what is a driven member and what is a driver member and what are the three different types of movements of the follower and some terms used in the radial cams and its applications. So today we are going to discuss about the classification of cams. So these are basically three types. So cams are classified according to their first one is the shape, second one is the follower movement, and third one is the manner of constraint of the follower. So these are the three types of classification we had in the types of cams, that is in the classification of cams. So let's see the first one, that is the according to the shape. So according to the shape, it has divided into many types. In that, first one is the wedge and flat cams. So in these wedge and flat cams, a wedge cam has a wedge W in which it is in general has a translational motion. So generally you know about the wedges. So these are all the wedge faces, that is the wedge cams. So three different types of wedge cams which is placed below the knife edge follower, roller follower. So these are the knife edge followers and this is the roller follower. So this wedge has a wedge W. So we have all indicated that these are the wedges. So W is indicated in between that, which has a translatory motion. So these wedges have the translatory motion in which it transforms the motion to the follower, and the follower F can either translate or oscillate. So according to the shape of the wedge, the follower can either translate or oscillate in direction. And a spring is usually used to maintain the contact between the cam and a follower. So generally in the first picture, so this is the first picture, you can see the both follower and the cam. So this is the wedge cam here, which can be moved on the either ways, and this is the knife edge follower which is placed on the wedge cam, and a spring is attached to the follower, and two slideways is placed on either ways of the follower. So the spring is usually used to maintain a contact between the cam and the follower. And in the figure C, that is the third figure, you can show the cam is stationary and the follower constraint or guideways G causes the relative motion of the cam. So that is these guideways is moving in the direction of horizontal. So that is it moves in the horizontal direction. There the follower is sliding in this stationary, and this is, and here the cam is stationary because there is no movement in the cam in which it is stationary, and the follower constant is G, which is related to the cam and follower. Next one is the second type, that is the radial or disc cams. So first one is the wedge cams and second one is the radial cams or disc cams. So a cam in which the follower moves radially from the center of the rotation of the cam is known as a radial or disc cam. So a disc cam may be termed as the in which the follower moves the radial in shape from the center of the rotation. And these radial cams are very popular due to their simplicity and compactness. So first one you can see the radial cams. So this is the radial cam which is moving in the clockwise direction. Clockwise direction, and this follower is moved based upon the profile of this cam. So whenever it is moving in the anti-clockwise direction, it is then projected towards the left side, and that is the anti-clockwise direction, and measure this profile of the cam and verify the profile of the cam. So you can see the guideways here. So these are the guideways, and this is the follower, and this is the cam. So that is the radial cam. Here in the second picture, you can see the disc cam. So this is the disc, and this is the follower to be fixed on this disc. And these are the guideways which is moved on either ways. Next one is the spiral cams. So a spiral cam is a face cam in which a groove is cut in the form of a spiral. So which you can show in the picture. So this is the spiral cut in which it is cut in the form of a face cam. So this is the face cam, and this is the follower, flatted follower, in which it is run towards the spiral groove of the cam. So in this spiral groove, this is going to be run towards the spiral. So a spiral cam is a face cam in which a groove is cut in the form of a spiral. And this spiral groove consists of teeth with mesh with a pin gear follower. So this is the pin gear follower in which a pin is set up on the lower end of the follower, and this is struck in the spiral groove. So this is fixed on the spiral groove to for as the attachment of the cam and follower. And the velocity of this follower is proportional to the radial distance of the groove from the axis of cam. So this is concerned to the axis of the cam, and the use of such a cam is limited as the cam has to reverse the direction to reset the proportions. To reset the proportions in it, it is used. So the use of such a cam is limited as the cam has to reverse the direction to reset the position of the follower to find it using the computers. It finds it using. So whenever we are going to start the cam, so this is the direction which is going to start, and this is the end one. So whenever you need to again rotate this, you have to follow and take this to the starting point, which is not a circular one. So that is the main disadvantage in this follower. Next one is the cylindrical cams. So one of the important cams in the classification. So in a cylindrical cam, a cylinder which has a circumferential countercut. So this is the circumferential countercut. So this is in the cylindrical direction in which the follower is used to move in the cylindrical groove. So that is the only type. The follower is used to move in its groove. So the follower motion is on the circumferential counter cut, and it is used in the surface which rotates about its axis. So this rotates about its axis, and the follower motion can be of two types. In the first type, a groove is cut on the surface of the cam, and a roller follower has a constrained oscillatory motion, that is constrained oscillating motion with respect to the direction, that is in the positive direction. And another type is an end cam, in which the follower of the end is in the working phase. So this is the end cam type, and this is the main type, that is the oscillatory motion type, and this is the second one, in which it is based on the working surface, that is it is the follower is based on the working surface. You can see it in the figure also, that is in the second figure. A spring loaded follower translates the or parallel to the axis of the rotating cylinder. So this transfers the along the parallel side or the axis of the rotating type also. Next type of cams is the conjugate cams. So a conjugate cam is a double disc cam, in which the two discs being keyed together and are in constant touch with the two rollers of a follower. So these are in the constant touch with the two followers of a roller, that is the two rollers of a follower. So you can see it in the picture also. So you can see that two discs, that is the first disc and the second disc. These two discs are in constant touch with the follower rollers, that is the two followers which we have seen or observed in the follower. So these two rollers are in constant touch with the two discs in the conjugate cam. So generally, this conjugate cam is a double disc cam, and thus the follower has a positive constraint. So generally, this follower has a positive constraint. Such a type of cam is preferred when the requirements are lower. So generally, the material used to be is very low in wear and low noise, better control of the follower, and high speed and high dynamic loads. So these are the requirements of for using the such type of cams. So whenever we had the material in such a low wear and low noise, and we need to be better control of the follower. So these follower has in constant touch with the two rollers of the follower of the two discs of the cams. So here in the picture there is two discs, that is cam disk 1 and cam disk 2, which are in constant touch with the two discs or the two rollers of the follower. So one side of the follower disc roller is touch with the cam disc and other disc is touch with the cam disc. And these followers has a very positive constraint because they are in parallel to each other and they have a positive constraint in between the followers. So these are the conjugate cams. Next one is the globoidal cams. So a globoidal cam has two types, basic, which is having a surface contact that is either convex or concave. So that is based on the type, whether it is convex or concave. And a circumferential counter is cut on the surface of the rotation of the cams. So these are cut on the surface of the rotation of the cam to impart motion of the follower, that is to impart motion to the follower which has an oscillatory motion. So this surface of contact has much oscillatory motion. And the application of such cams is limited to moderate speeds and where the angle of oscillation of the follower is very large. So there are two pictures in this slide. First one is the convex surface and second one is the concave surface. So in the convex surface, you can see the surface which is mounted on the follower. So this is the shape of the cam in which it is placed below the follower, and second one is the concave surface which is somewhat less than this. So that is the shape of the concave surface is tilted towards the lower end from the ends of the cam to the center of the surface. So the follower rotation is like this. So you can see the difference in the global cams, in which basic it has a convex surface and the concave surface. So next we can see the spherical cams. So in a spherical cam, the follower oscillates about an axis perpendicular to the axis flow of the surface of the rotation. So of the surface of the rotation. So we used to note that in a disc cam, the follower oscillates about an axis parallel to the axis of rotation of the cam. So generally it is used in the parallel to the axis of rotation in a cam. And a spherical cam is in the form of a spherical surface which transmits the motion to the follower. So generally it is used to join the, or it is used to transfer the motion of the follower. So in the picture you can see the difference there. So this is the follower and this is the spherical cam. So this is the groove which is fixed on the spherical cam, and the follower is used to move in this groove only. So this is the spring motion. So this spherical cam has a follower which is oscillating about an axis parallel to the axis of rotation of the cam. Generally, this is occurred in the spherical cams. And next we can see the according to the follower moment. So the motion of the followers are distinguished from each other by the dwells they have. So dwell is the moment. Dwell is the moment in which there is no motion in these follower. So there is the motion that the follower is in the constant motion. So there is no regular motion, and a dwell is the zero displacement or the absence of the motion of the follower during the motion of the cam. So in this dwell period or the motion period, it does not have any displacement. So it does not have any displacement, and this has the absence of motion of the follower during the motion of the cam. And these cams are classified according to the motion of the followers in the guideways. That is, in the guideways, it can be used. So first one is the tripler, that is the rise, return, rise movement. So it is also called as RRR, that is tripler. In these, there is alternate rise and return of the follower with no periods of delts. So you can see it in the picture. So the starting point of the follower is like this of the profile. So it will rise and then goes to the point, that is the cam angle point, and then return to its original position and return to its original position, which have no period of dwells. So these positions have no period of dwells. And its use is very limited in the industry. So without the dwell periods, there is no one. So that is, its use is very limited in the industry, and the follower has a linear or an angular displacement curve. So the follower generally has a linear motion or an angular displacement motion regarding to this. And second one is the dual rise return dual. So the form is DRRW, that is dual rise dual, and next dual rise return and dual. So in these types of cams there is rise and return of the follower after a dual period. So after some amount of limited time of dual period, it has dual period after the after and below the rise and return of the follower. And in such a type there is rise and return after the dual, and this type is used more frequently than the rise return rise type of cams. So in the industry we can use these type of cam motions because there is inclusion of these dual periods before the rise and return of the cam following. So therefore it can be used frequently than the RRR type of cams. So here it starts with the dual period. So this is the dual period, and then it will rise to some extent, and this is the cam angle here. Then it is then return to its original position, and then there is some dual period. So again there is some dual period in that. Next one is the dual rise dual return dual. So in between every section of rise and return there is the dual time. So there is the dual period. So this is the mostly common type used in these industries. So mostly common type of one which is used in these industries. So it is the most widely used type of the cams. So these type of cams has been widely used. The dwelling of the cam is followed by rise and dwell, and subsequently by return and dwell. So it is then ended with the dwell period also. So you can see it in the picture also. In case the return of the follower is by a fall, the motion may be as dual rise dual. So in case the return of follower is by falling method, that is from the dual position to the falling one, it start with the dual rise and dual. So these are the three positions. So you can see the picture, that is the starting with the dual position, and there is rise position again, then it is dual, and then it is return, and next is the dual position. So it is the most commonly used type of the cams. The dwelling of the cam is followed by the rise and dwell, and subsequently by return and dwell, which is shown in the figure. That is the first picture. And this return of the follower is by a fall, and the motion may be dual rise dwell. So when the return of the follower is suddenly to breaking this point, so then it is dual rise dwell only. Next, get to the last type, that is according to the manner of constraint of the follower. So manner of the constraint of the follower. So in these, to produce the exactly the motion transmitted by the follower to the cam, that is the cam to the follower, it is necessary that these two remain in touch at all speeds and all the times. This tends to be in contact with the all times. So the cams can be classified according to the manner in which this is achieved. So according to the manner of the achievement also, these are going to be taken. And first one is the preloaded spring cam. So preloaded spring cam. So a preloaded compression spring is used for the purpose of keeping the contact between the cam and the follower. So this is used to in the contact of the follower only in all the ways. And second one is the positive dry cam. So in this type, constant touch between the cam and the follower is maintained by a roller follower, which is operating in the groove of a cam. So which is used to be operate in the groove of the cam. And the follower cannot go out of this groove under the normal working operations. So this cannot be done without the conjugate cams. So a constant or positive drive is also obtained by the use of the conjugate cams. So it is highly used in the use of the conjugate cams. And the follower cannot go out of this groove under the normal working operations. So generally it is not go out. And last type one is the gravity cam. So if the rise of the cam is achieved by the rising surface of the cam and the return by the force of gravity or due to weight of the cam. So due to the weight of the cam, we are going to achieve this. So if the rise of the cam is achieved by the rising of surface of the cam and the return of the surface, the cam is known as a gravity cam. So it is by the force or due to the weight of the cam. But nowadays these cams are not preferred due to their uncertain behavior. So due to their uncertain behavior, these cams are not used in these days. So these are the different types of classification of the followers. In the next class, we are going to see the classification of the followers also. Thank you.